almost want some intro music. Well, ladies and gentlemen, welcome. We're here live. Kubewarden is actually going GA almost as we speak. I'm joined by members of the Kubewarden team, not the entire team. So I want everyone to know that there is a lot more of people behind this team than the three that you see here. But I am joined by Flavio, Raul, and Victor from the Kubewarden team, and we're going to actually watch them flip the switch from, I don't know what the current version is, over to 1.0 and to our GA of Kubewarden. Now, if you don't know what Kubewarden is, we'll talk a little bit about what. Flavio, I'm going to turn it over to you. Let's share and let's flip this over and go.
Yeah,
live.
Sure. So, hi everybody. Super happy to be here with you, sharing. It's a pretty significant milestone for us. So Kubewarden is made by different components. So we are going to go through the major components. So we will start with a Kubewarden controller. All right. So here we have been doing some testing. So we reached RC4, but now everything is mature enough, and so we are going to tag the final release. So this is pretty straightforward, and then I'm going to push that to my fork. All right. And then I'm going to push that to the upstream repo. So now let's go down there. The controller has been updated because I created this patch. We have everything automated. So if I go under the actions page, I can see that, the V1, a couple of V1 jobs are being executed. So there is some CI stuff, but the really important one is this one about the container image. So this is going also to take more time because we're building the container image for the Intel architecture and for the ARM architecture. So this takes a little while. There is also another job that takes a little while. So if you don't mind, I would start it before, then we can chat about all these components. So this is about the policy server. This is a Rust project, so we have to update the version in there. So it's 1.0. I will create a special branch for it so that others can go through the pull request and review it. So I have to rebuild it in part because the cargo log file has to be updated. So yeah, 2 files have been changed. That's good. Now let's create a pull request for that. I'm going to create it against the upstream branch. I'm using the GitHub CLI tool. We can talk about that if you're interested. And so this is submitted. So let's see that one. Here we go. So maybe Raul, Victor, can you take a look at that? In the meantime, great, thank you. In the meantime, let me add it to our board where we keep track of all the development. You can see here, where is this one? Some actions are being run in the meantime. These are just continuous integration actions. So code formatting, linters, the unit test. I see Victor approved it. So usually I would say, let's wait for everything to be green but we know that everything is going to be green because we didn't do any change since RC4. Oh, Raul, thanks. So I'm going to merge it. I'm going to delete this branch from my fork. And now I have to do the actual tagging. So let me sync with upstream repo. Yes, we are doing good. Let me push the changes to my fork. And now let me do the tagging. I push the tag to my fork. And now let me push it to upstream.
All right, so as this is going, let's talk about a little bit for those who are joining us now who might not know what Kubewarden is. And I'm going to let Flavio and Victor and Raul, I know you're kind of pair programming with him, so if he's making a mistake, jump in and interrupt me, and make sure he doesn't mess this up. I think Matt Farina messed it up when he did Rancher Desktop, but to be fair, he didn't have anybody but me, and I wasn't paying attention. So anyhow, for you guys who are here just joining us, Kubewarden is policy as code, and it is done in such a way that allows you to write specific policies to secure and maintain your Kubernetes clusters. Now, what is awesome about this is that it is written in WASM, and if you're a developer and engineer, I say the word WASM and people lose their mind because it is the one technology, no matter who you are writing code, you want to touch, you want to handle. But that's not why is it exciting? Why it's exciting is if you've ever had to maintain, and before my earlier, I'm going to say my pivotal Cloud Foundry days, I had to maintain my own Foundry. That's what we used to call Cloud Foundry instances. And developers used to run amok in there. And when I came to SUSE, Kubewarden was one of those projects that I looked at going, I know the pain and the use case intimately. So it allows you to put policies in that now can monitor. I'm not sure if that functionality is in there, but you can monitor, mutate, accept or reject anything that you're doing within the cluster. And it's a very, very powerful tool to help secure down. Now, I might have missed something. I'm gonna let Flavio. I'm gonna let Flavio come in and make sure I didn't miss anything in that explanation. Is that pretty spot on?
Yeah, I would say so. So the main goal of Kubewarden is to keep your cluster secure and compliant, which are similar topics, but there are also differences in between. So you can use concrete use case, Kubernetes pod security policies. I guess everybody knows that they're going to be dropped by the next Kubernetes release. So the pod security policies have been used by a lot of people to keep their cluster secure, like preventing users from running privileged containers, or preventing users from, trying to escape from a container by leveraging some vulnerability with how mount points are handled, or access portion of the file system with all this kind of stuff. So now that pod security policies are going away, what can you do? This is a need. This is a need that Kubewarden can satisfy. You can use Kubewarden policies to basically replace all the pod security policies. And by the way, I know that there is a pod security feature which is going to partially replace pod security policies, but this is a partial replacement where it doesn't cover all the use cases of pod security policies. But with a policy engine like Kubewarden, you can keep your cluster secure, and you can even create new policies for preventing other kind of attacks that pod security policies didn't even imagine. So this is for security. For compliance, what you can do is you can enforce certain rules to be followed by all the users of your cluster. Like you might want to have a certain label to be attached to all deployments, for example, or to all namespaces, because then you can do accountability, cost counting, I don't know. And there are many scenarios. And this is yet something that a policy engine like Kubewarden can help you with. So, yeah.
So one of the things I like to remind people is just because you can write up your own policies, so either in Rego or Rust or anything else that compiles to WASM, but we always recommend that you check out the hub first, and that's hub.kubewarden.io. The link is Policy Hub right there. You can go select that. The Kubewarden team, people like Victor and Raul here, help maintain these policies. These are kind of, I don't say homegrown policies, but no better way of calling it. But the Kubewarden team does have a lot of these common use cases. So instead of reinventing the wheel, we always recommend that people come to the hub first, check it out, and understand it. Now, as the builds are going, one of the things that I wanted to bring up is some of the new features and functionalities that this release had. So I want to flip it over to Victor. I'm going to put you on the spot here. We had some things with observability. Do you want to talk about that?
Yes. So maybe you, Robert, didn't follow the latest things. But yeah, we have monitoring and observability with our policies and so on. Monitoring would be the usual approach where you just deploy the policy, and the policy can tell you if things would be accepted or rejected, but it allows everything, so you can just monitor and learn from what's happening on the cluster and what would you like to set up and your cluster with the policies. And yep.
Real quick with that, how does that work with people writing policies and tying into observability? Can you unpack that a little bit?
Well, if you're talking about observability in the sense of Grafana, Prometheus, Jaeger, and Open Telemetry, all of that ties with what Kubewarden already provides. We have Helm charts, and you can deploy the Helm charts, configuring them to use a Prometheus instance that you have, an Open Telemetry collector that you have, and to deploy Jaeger and have everything there. We have all that in the docs. And if you do that, what you end up with is that all the information that comes from the policies rejecting or accepting things in the cluster, when you just try to instantiate a pod or an ingress or whatever, all of that is available in those things. So you would get a nice Grafana dashboard with the things as Flavio is showing, was showing before, or you would get the Jaeger tracing with all the tracing and all the microseconds that takes the policy to trigger, which is, we are happy that it's so fast, and things like that. So yeah, this is super broad, but yeah, I'm super happy about it.
Awesome. One of the really cool things that we are able to do is to really treat policies. I mean, policies are code, and everybody says that, but in our case, the integration is so deep that they can be seen like microservices as well. So we have all this integration that Victor was mentioning with telemetry through. We are leveraging Open Telemetry, and basically the policies are able to emit trace events like any kind of microservice would be doing. So imagine yourself being an operator and trying to figure out what is going on with a policy. You are getting a lot of rejections happening inside of a cluster. So you can maybe start by looking at the Grafana dashboard and figure out which is the policy that is triggering all these issues. And then you can open your Jaeger UI, and like you would do while debugging a microservice outage, you can find trace events about specific policy evaluation. And then you can look into the trace event itself. This is like if you ever used Jaeger, I mean, this is the usual workflow that you would go through. So you can drill down and see, okay, there was this information was received by policy server, which is the component that tagged before, which is actually running the policies. And you can see what came in. And then you can start to drill down and look into the actual policy trace events emitted by the source code that the policy overwrote, and see the timing of all the different events, how much time it took to complete something, what kind of log messages might have been provided by the policy, the return message that was provided by the policy, the code, all of that. So this is like debugging usual applications, and that applies to policies as well. So I think that's pretty valuable.
it almost kind of shifts the paradigm out where it's treating these like a observable microservice, so you can debug either the component themselves, the WASM file, or you can be debugging what you're attempting to do that the policies either rejecting or mutating, or or in that regard. So you have observability, so now you can actually dig down into the rules that are being applied, or the policy that's being applied, and it's I don't want to say game changer, but that's a really powerful thing to see. Is it on the policy side, or is the policy acting as intended, or is it on what we're trying to deploy, and is it there where it's failing out? And so that's really an awesome feature that I'm happy to see added to the Kubewarden project.
Yeah, and if I can go back to the policy hub just briefly. As you were saying, Robert, we have many policies over there. So, for example, all the pod security policies that I was mentioning before. So we have a one-to-one mapping to what pod security policy used to be and the new version of it done with Kubewarden. And we are basically doing exactly what PSPs were doing. Which means that the internal code of a policy in some cases can also be quite complicated, because PSPs were complicated in terms of implementation code. And we are able to do mutation as well. There were some pod security policies that were performing mutations. And this one, allow privilege escalation, you can see there is a pencil over there. That means this is a policy that performs mutation. So it can change an incoming object. And side by side in the hub, you can find other policies that are more about compliance, maybe like safe labels or safe annotation. So enforce that a certain label or a certain annotation is found or is not found, is prohibited, or when it is found, it must comply with certain rules. So there are many policies for different things. I don't want to anticipate something because I know you want to talk about that later. So, but there is a policy over there that is pretty interesting, and I guess we will talk about it.
So I'm gonna let you take a moment, flip back, and see where your build process is at. I know we're in the middle of that, but when you're done, I'd like to just ask about those green check marks and why those are so important.
Yeah, so let's take a look. So as I was expecting, building the container image is still going on. It's taking more time. That's the controller. And then we have to, that is another pull request that we have to look into later on. Let's see how the policy server is doing. Yes, it is still building. There is also another thing which, if you don't mind, I would like to release. I would like to tag.
Sure.
So this is KWCTL. It's our command line tool that policy author can use when developing a new policy, when trying it out, but is also useful for operators. So people who discover a policy, like on the policy hub, and want to try it out locally without using without the need to have a full Kubernetes cluster up and running. So let me tag a release of it. Again, this is a Rust-based project. So let me update the version number. Let me force an update, a refresh of the cargo log file. Let me create a new branch for that. All right. Let me create a pull request for Victor and Raul to review.
I can see those two over there just wondering if they can reject it just for funsies since we're live. They thought about it. I can see it in their eyes. Hey, let's reject it and see what happens.
And here we go. As usual, there are a bunch of checks that are going through. And again, we will not wait for all of them to be green before merging it, because we didn't introduce any change since RC4. And thank you, guys. So let me merge it. Now this is merged, and now we have to tag it. So let me sync with upstream. Let me push the changes to my fork. Let me tag the release. And let me push the tag, which is going to trigger the release pipeline, which is going to be faster. So in the case of KWCTL, we have this release action, and this release action will build a binary for Linux, Linux Intel, Linux ARM, and then for Windows and for Mac OS. So, and everything is going to be released under the release page of GitHub. So yeah, I'm over, Robert, if you want to.
All right, so let's, if we can go back to the Policy Hub page, I want to talk about something that's kind of, I don't want to say, to me, it's really important, because every year we tell ourselves in the Linux, the open source community, this is the year of the Linux desktop, and every year we're wrong, but I think it's fair to say that this is the year for security. It's been front and center through and through, and Kubewarden is a security tool for Kubernetes. But there's a little green checkbox by a lot of these policies, and they're 6-source signed. So I'd like to take a moment and talk about the importance of that and why, because I can talk about, I know why here at SUSE, why we're hell-bent on making sure that everything is secure. But we were some of the, on our teams internally, we were leading that charge with 6-store. So Flavio, if you want to take a moment and explain what the sign policy is and why we went this direction.
Yeah, sure. So basically, our policies are distributed as WebAssembly modules. So for the ones who are not familiar with it, a WebAssembly module is just a binary blob. You compile it once, and then you can deploy that on any kind of platform where you have a WebAssembly runtime without doing any recompilation, any change. The problem with this approach is that these are binary blobs. So as an end user who is about to deploy a policy inside of your cluster, how can you be sure that this policy is not going to do something malicious? Because let's not forget about that. Policy engines, they are pretty powerful. And so if abused, they can become really a big concern from a security point of view. So in order to prevent that kind of attack, I think it's really important to have a way to verify what you're about to deploy in your cluster. And so we decided here to leverage the 6-store project as a way to sign and verify our policies. And I bet many of you have already heard about 6-store. It has been an incredibly successful project. 6-store is already being used to sign and verify container images, and it can potentially do many things. I think a couple of weeks ago, they even announced a way to sign your Git commit messages using 6-store, so that you don't have to deal with GPG keys and all the pain that comes from them. So it's really an interesting project. So going back to your question, Robert, so all the policies that the Kubewarden team is maintaining and is delivering are being signed with 6-store, and you can then verify them before their execution. So you can be 100% sure that these policies have been done by us and nobody has tampered them. You can also, both as a developer and as an operator, you can also re-sign some policies. You can, if you are a developer writing your own policy, you can sign it like you would normally do with a container image. And then you can ensure that when running your policy in production, the policy that is being deployed is yours only policy. Nobody tamper that. As an operator, you can verify the policies that are coming, but you can also leverage that to implement some compliance checks. There are many organizations where, for example, only certain vetted container images can be deployed inside of a cluster, and that can apply also to policies. Only certain kind of policies can be enforced inside of a cluster, and there is a limited trusted group of operators that are the ones who vet policies or container images. And so these trusted administrators, they can take a policy and then add to it their signatures. And in this way, you can end up having our policy server configured in a way where only the policies that are signed by all your trusted administrators can be enforced in a cluster. Or maybe, you can even come along with some fancy setting, like say, I have 3 administrators. I just need 2 out of 3 to have signed a policy in order to be enforcing it. So this is pretty flexible, and it opens to a lot of workflows that many organizations have already in place.
Awesome. I was talking to mute there. So as we're waiting for our final builds to go through, and hopefully we can do it on the time we're allotted today, some of the things that I wanted to make sure we talk about is the fact that we are doing a global online meetup here on July 13th. Details will be coming. So if you follow us on LinkedIn, Twitter, Twitch, or even YouTube, these things will be posted there. You also find it at community. That's Tuesday.com/events or Tuesday.com/events. Those we will go on meetup. We're going to do So are we? I didn't look. Are we done? Is it over?
Can you still hear me? Because I had some network glitch. I think everything was slowed down over there.
Yeah, we can hear you.
Okay, good. So I didn't get anything of you said during the last minutes because it was all garbage here because probably my machine was under some load. So can anyone else over there answer a question, please?
I was just asking if our build is complete. So if it is, then seeing enough and kind of a lot for this live stream here. We have a few minutes left.
I can't hear him.
Can't hear me.
You're breaking up.
Ah, okay. So it's not an issue on my side.
Yeah, I think we're losing Robert.
Reassuring.
So
okay.
Yep. Well, I think Robert was asking for the builds, and they are really close because I see the latest libraries that we depend on already being built. So
yeah, the controller is ready. I can see it. While the policy server is still going on. Let me double check the KWCTL build. Now, the really important things that we have to wait for are the container images. That's because we have to update our Helm charts. The Helm charts are what we use to deploy Kubewarden. And so speaking of that, if you don't mind, I would go ahead and update the Helm charts.
Yeah, sounds good.
Yeah.
What do you think, Raul?
Yeah, I think that makes sense. I think the policy server will be also ready in a few minutes. So.
Can we hear me now, or is it
yes.
not working?
Now it's better.
Yes.
We can.
All right. Well, we're about at time. Looking at it right now as we're going through, but I want to let everyone know who I cut out saying it, but we have a global online meetup where Flavio and maybe Rafa or Victor, someone's going to come back with Flavio, and we're going to take a deeper dive with Kubewarden. That's coming up July 13th and about 1 p.m. Eastern time. So more information will be released on our Twitter, Twitch, YouTube channels. And if you always want to find any with the latest and greatest of events, it's community.suse.com/events. It'll be posted there as well. So feel free to sign up, keep yourself informed of what's going on. And I think give it another minute or two and hopefully we can be done.
Yeah, it's looking good. We are on the last piece.
We're right there. We'll go a little over time. It's okay. I don't think anyone's going to yell.
In the meantime, there was something I wanted to talk about. Maybe
Sure.
Raul can cover that, which is to go back to the SIG-Store integration. There is a policy that Raul and Victor wrote that I think a lot of people will find pretty useful.
Yeah, I think you're talking about the verify image signature. So in addition to verify your policies, which you should do, as Fabio mentioned, you can verify your container images. You can use Cosign to sign your container images in your CI/CD pipeline or wherever you want. And then you can use this policy to verify the signatures. And this policy will verify the signature before it goes into your cluster. If the signature doesn't match, it will reject the pod. If the signature verification is successful, then it will allow the pod to go into your cluster. That way you can verify, make sure that only trusted containers goes into production.
I had a network glitch. I think my browser is eating a lot of memory.
But so far it's going well. That's the last. The last. No, we only have the Helm charts to release, and I think we are done.
Yes. We have a blog post to be pushed out, but we can do that afterwards. So please review this one carefully, just to make sure I didn't do any mistake. And so the controller is out, I can close it. This is the policy server, which is still going on. It's still building for ARM. Yeah, this takes more time because we're doing cross compilation.
Okay, but I think it just finished because it was uploading. Yeah, no?
Oh, yes.
Yeah.
Perfect.
And now building the binary is what takes a lot of time. Building the container image is going to be super fast. Let's see. Yes, this is going to be quick.
Yeah.
And do we have other things to do, folks?
KWCTL.
Yeah, I take it. Yeah.
I think we are set, no? I mean, blog post and maybe celebrate.
Yes, that would be a good idea. Yeah, this is done. Now we're going to, as you can see, we're also here, we have steps to do signing with SIG-Store. So not just our policies are being signed, but also our container images are being signed. Also, our Helm charts are being signed. Everything done with SIG-Store. And yes, everything is ready.
KWCTL as well, the binary is also signed.
Oh, yes.
So yeah, we're signing everything.
That's true. Yeah. So that means we can go back here. So this is done. And KWCTL is still building, but we don't care. I can close it. You reviewed that, so I can merge it. And there is nothing to be tagged over there because we have a pipeline that takes care of tagging everything. So this pipeline is running now, the release Helm chart one. And usually this is really, really fast.
Meanwhile, we lost Robert, so maybe I'm picturing Robert asking, okay, and what's the sneak peek of next things coming to Kubewarden besides 1.0, after 1.0?
Oh, that's a good question. What do you have in mind, guys? I have something, but
yeah, I don't want to spoil much. I remember also the blog post, no, the upcoming blog post having maybe some things. But
yes, yeah. Oh well, let's talk a bit about that. So there are, let's say, some developer-focused efforts. So we have been working silently, but everything is in the open, in improving the developer experience for writing Go policies. This is actually already live, but we want to do a blog post about it. So in the past, writing policies with Go was not so smooth as we wanted, and that's because of some limitation with Go, and basically the lack of Kubernetes objects. But now we found a solution for that. We implemented something pretty neat, and so that means that you can do policies in Go like in a really native way. All right. And everything is already documented inside of the main documentation. This method is also going to allow us to do mutating policies with Go, which is something that was not doable before. There are some things that are broken that we have to figure out, but we will definitely talk about that. So this is a pretty big thing that is coming up next. And
I'm back.
Oh, hi, Robert. So while you were away, we basically we tagged everything. So
we're done.
We are basically done. I assume, I wonder why the release is not up there, but the Helm chart has been merged. And we should be seeing, a V1 Helm chart being served.
Maybe the network issues that I'm having, GitHub's having. That's what I'd like to just say.
Oh, here we go. Yeah. Oh, there is a problem, I think, with GitHub. Why is it marked as latest? This should be the latest.
Yeah, that should be pre-release on GitHub.
Yeah.
All right, guys. Well, we're way over time, our normal streaming time. I think, I'm not sure. My internet outage was here locally, not on our streaming platforms. But I would like to wrap this up again. For anyone who didn't hear me, if you have questions, go to community.susa.com. We can answer your questions there, or you can go to the slack.rancher.io, our Slack channel as well. There's a there's a Kubewarden channel in our Slack instance. Ask your questions there. Do not put it in general, because generally it doesn't get answered in general. So go to the Kubewarden channel on the slack.rancher.io. And as these guys are wrapping up, I want to just do one last plug. We are going to do a global online meetup once again for Kubewarden, July 13th. I want to thank everybody, Flavio, Victor, Raul. Thank you guys for coming on. This is not the whole team. They represented it, did a great job representing, and they did a great job presenting when I wasn't even here. Makes you question whether they need me here or not. So thank you guys, and we'll see you guys in the community.
Thank you. It was a pleasure. Have a great day.
Thank you.